Good afternoon, class. In today's video, what I'd like to do is to go over the exact same equation that I did in the last video of aluminum carbonate plus hydrochloric acid to give you aluminum chloride plus H2O plus carbon dioxide. I wanted to do the same problem, but I wanted to show you a different method because I recognize that sometimes this can be difficult, especially to balance all these chemical equations, and sometimes multiple methods could be better. So if you like this method, great. If you don't, if you like the other method from the previous video, you can use that one as well. Either way, it doesn't bother me. So here's the second method. Again, you see it's the exact same problem, so we know from the last video we have the exact same answer. The difference is when I actually put into the balancing part. So in this case, what I do is I take this aluminum, instead of just writing aluminum as my one element, I write aluminum 2, which matches over here. That way, when I put the coefficients in, everything kind of lines up. So I have my aluminum 2, which is 1, because I put the 1 coefficient here. The carbon atom has 3 attached to it, so that's why there's a 3. And the O3, which makes up this carbonate ion over here, still has 3, so there's 3 O3, I want to say molecules. And then, of course, hydrogen and chlorine are singular, so that 6 goes over there just like it did in the last one. So then what I do over here is this way, and what you'll notice is these coefficients. So what I fill in over here is all of the products. So 1 aluminum, 3 chlorines, 2 hydrogens, 1 oxygen, right? So 1 aluminum, 3 chlorines, 2 hydrogens, 1 oxygen. Then, of course, 1 carbon and 2 oxygens, so 1 carbon, 2 oxygens. Some of you might say, well, that doesn't seem very efficient because the oxygen and the singular oxygen and the O2 molecules are sitting over there separate. Shouldn't they be together? Well, that could be a thing, but that would be the previous method. So if you object to this, what I did over here, then you might be considering using this the previous video's method. So that's up to you. So because the reason why I do this is because, especially on this side, everything looks a little bit more complex. So what I'm doing is I'm just matching what I put over here as the products with their coefficient. So I've got a 2 here, so I put a 2 here and a 2 here because that's aluminum chloride. I have a 3 here, so I'm going to put a 3 here and a 3 here because that's, water. And then a 3 and a 3 because there's a 3 right here for carbon dioxide. And then, of course, after that, now I just have to do some multiplication and addition. But instead of doing all of that up here, and a lot of times people do this in their heads, like they'll do the conversion over here, and then they'll write it down over here. This way, you don't have to do any of the math in your head at that point. You can write it all down first, and then you can do the math after it's all written down. Some people tend to like that a little bit better. I thought that of that method as a way to maybe help. So if it works, it works. And don't worry, the answer is exactly the same because we take a look at this. There's 2 aluminums on this side, right? Because 1 times 2 is 2. There's 1 aluminum on this side, but there's a coefficient of 2, so 2 times 1 is still 2. Chlorine has 3. There's a 3 chlorines here, but it's times 2, so that's 6. And we have chlorine. There's 6 chlorines over here. When it comes to the hydrogens, H2, 2 times 3 is 6, just like what we have over here for hydrogen. Oxygen has 3, but there's more than that, so we just leave it for now. We look at the O2, and there's 3 of them, so 3 times 2 is 6, plus 3 is 9, which is 3 times 3. So, it still balances, and the carbon, there's 3 of them here, and there's 3 of them here. So again, everything balances. It's the exact same answer to the equation. It's just a different method of drawing this bottom part out so that everything, I don't want to say it looks easier, but at least it can appear to be a little bit more doable depending on not just the chemical reaction, but I mean just what state of mind you're in at that point. Because some people, they love this method, Some people love the one from the previous video. And I myself will go between both of those, whichever seems more convenient, based on whatever the chemical equation that I need to balance is. So, don't feel like you have to use this one exclusively or you use the previous video's one exclusively. You can, whichever works for you is for you. I just wanted to give you two different methods for how to solve something like this, especially as you get into more complex double replacement or such reactions like that. So as we get into more complex ones, you have multiple methods of solving these problems. So that concludes how to balance chemical equations. Good luck in your studies.